So how do we actually go about monitoring earthworks? We can use slip indicators. They're an old-fashioned qualitative method. They give the depth of movement. You pass different lengths of brass rods down a thin alkathene tube and then measure the length of the string where it stops. They're quite old-fashioned, but it's amazing when we go to visit new slip locations just how many of those we find in the ground, which maybe says something about Network Rail's and British Rail's record keeping in the past. Inclinometers, that's the modern equivalent. They're grouted into window sample holes or drilled boreholes, and they measure movements quantitatively using an electronic tilt sensor. And they give a measured vectored movement at half-metre intervals, and it's accurate to 0.5 millimetre per metre. Piezometers, there's various types, but they're used to measure water levels and particularly water pressures in banks. Water pressures are often the critical destabilising action in soil mechanics problems and design. Really, any remedial design I see which doesn't show water levels or state what assumptions have been made regarding water pressures in the slopes, I would really regard as deficient. So piezometers are very useful. Topo surveys, they're a fairly simplistic tool. Pegs are put into the ground. We use these to look for more translational shallow movements in the slopes. Repeatability, accuracy, loss of pegs can be a problem, but providing they're read regularly, this can be fine. You've got to make sure that your TBM is a long way from the moving area though. Putting TBMs on OLE mass bases on top of the moving embankment isn't generally recommended. We can't always stop the bank from moving, or we need to run trains while we mobilise the works. So we can manage this operationally by installing monitoring that gives us a warning. We can use cant sensors fixed to the sleepers. These give us a text alert when there's a given twist, and that replaces manual reading with a cant meter like this. We've done recent trials using sonic, fibre optic, acoustic sensors fixed to the slope, and where these will give an alarm when movement's recorded, but there'll be more on these later. We can link them up to CCTV systems and weather stations, and again we'll show you some of that in the example sites. The limiting factor on them though is usually a regular power supply or having solar panels that don't get stolen when you're trying to read them. So what's an appropriate remediation? Wherever possible, we usually try the most economical method, which is to slacken the bank off to 1 in 2 within our boundary fence. Where there's not enough available space, we tend to use a gabion wall solution. Where global stability is not a concern and the embankment's on firm foundations, localised grouting and cess support systems are often utilised, but they need to be fairly local because putting them in over long distances can be expensive. They're generally done from trackside, so they require possessions to install because you're within the track support zone. Berms, half height or full height berms, provide a towway of engineered fill to counter rotational movements. They're often installed in short lengths. With trains moving and close monitoring of the track before, during and after the works to ensure that they're not causing additional settlement. You obviously don't want to put in a solution that makes settlement worse. Reinforced earth and sheet piled solutions, better for new embankments. They require large compaction plant, cranes, etc. to install. But these are significantly more expensive than a regrade. However, they do save space at the toe. You often tend to see these solutions more towards major conurbations and in central London. Where spacier access is at a premium, board piles, king post walls can be constructed. They're the sort of the Rolls Royce of remedial works. They require heavy manpower and plant to install. Again, possession costs. Generally, you're talking over £1 million per 100 metre length for these sort of solutions. Where scour is an issue on embankments, we generally use gabion walls, stone pitching, riprap or Reno mattresses. They're the preferred solution, and they're usually favoured by the Environment Agency from a habitat point of view. A more hard solution is usually sheet piled walls, which we have used green solutions such as willow stakes and coir rolls, and they can be used to repair local scour. In cuttings, regrading the slopes with or without land purchase at the crest is the most pragmatic solution to slope remediation. Where land can't be purchased, then removal or replacement of the material with large frictional stone face is used. Where we can't purchase land at the crest, then improving crest and slope drainage, removing vermin, installing counterfort drainage, etc. will all improve the resilience and life of the cutting. We do often also install catch fences at the toe and netting to keep things from falling on the line, and find these very cost effective in relation to the derailment risk that a large block would cause. So if we move on to some case histories, going to be moors on the Allington to Barkston East line. We were given a warning from the TME that material continued to fall onto the line, and then we started to get reports that the track was moving, indicating that there was something more serious than the rabbits and the steep slope that we thought was the problem. We put in some temporary works, which was a small concrete catch wall at the toe. That lasted four months before it started moving, and the toe wall started cracking. We then started to take things a bit more seriously. We cleared the vegetation, and we put in some inclinometers. But as part of the clearance, we identified that the local landowner had built up the land about 2.5 metres. That's our boundary fence there, and that's natural ground level. He's built up his ground level by that much at the boundary, and then put half a construction yard on the crest. So we did a few more temporary works, something a bit more robust. We've driven in old rail 4 metres deep, and we've put 1.5 metre sleeper wall in there. It's continuing to move, but we're monitoring. You can see how much he's built up his land on that side, and that's the driving force to the slip. We've got cant sensors on the sleeper wall, so if the slip reaches the timber wall, we'll report it. We've got CCTV cameras on it day and night, and they show this, and we get readings from the cant sensors every 5 minutes. This is what it looks like at the moment. As I say, you can see the amount he's built it up. The proposed solution is to buy some land off him, remove all that material, and take the driving weight off. And where we've already got the slip, to put in a shear key and slacken off the slope.